Look at another rule that we have. Another rule has to do with quotient of powers. So we're going to put that right here. Okay, so quotient is a big fancy word for dividing. So if I have two numbers that are being divided, so if I have a to the m, and that's being divided by a to the n, and it really doesn't matter if it's m, n, x, y, z, whatever, okay, that I have these two bases are the same and they're being divided. So what we're going to say here is, I'm going to just put my arrows like this. So we're dividing same base. So what are we going to do? Well, when we divide the same base, that means that we're going to subtract our exponents. So there's two different ways that we can do that. There's my base, so I could have m minus n. Notice I took this n from the denominator and I'm subtracting it from the m in the number in the numerator. Okay, so that's one way. Or I can also go the other way. Or I can bring this number down and subtract m from n. So then that would leave me with a 1 in the numerator. I'm going to change the color of that. I really don't want that red. And then this is going to be n minus m. Okay? So that's going to be 1. I like that. Okay, so it can go either way. And sometimes with the numbers you want to make a decision on which way you're going to go. So when we're dividing the same base, we then want to, subtract the exponents. Dividing same base, subtract exponents. Okay, so let's look at a real life problem here. Something that's got a lot of stuff going on. So I'm going to have 8 x to the 7th y to the 4th z squared, all divided by 2 x to the 3rd y, and z to the 4th. Okay, so there's a lot going on there. Okay, so we know, looking at here, 8 divided by 2, so 8 divided by 2 is going to give me 4. Now I want to be very careful on what's going in the top and what's going in the bottom. So I'm going to look at my x's, same base. I'm going to look at my exponents. Well, 7 is a larger exponent than 3. So it would make sense for me to move that 3 up here. I'm going to subtract 3 from the 7. So that's going to give me x, and that would be 7 minus 3. So now there's no more x in the denominator. So let's look at the y. I have y to the fourth over y. So we have to remember here that there is an exponent of 1. That's y to the 1. It's not written, it's understood to be there. So 1 is smaller than 4, so it makes sense for me to bring that 1 upstairs. So that would then be y, 4 minus 1. So there's no more y in the denominator. So let's look at our z. Notice this is 2, the exponent is 2, and our exponent here is 4. Well, 4 is a larger exponent, so I'm going to bring that down. So that then would give me z 4 minus 2. So when I go to clean up this whole thing, that's going to give me 4. I'm going to keep track of what's in the numerator and what's in the denominator, and I'm not going to move them because there's going to be nothing to tell me to move them. So that's going to be x, 7 minus 3 is 4. And that's going to be y, 4 minus 1 is 3. And then my z is in the denominator. And 4 minus 2 is 2. So that's what this expression is simplified. Okay, there are a couple more that we need to know. So we're now going to look at power of a power. So that's our new